Hello everyone, I hope you are doing well. In this video, we will explore how to apply the binning technique to a dataset using Tableau. Binning is a method that streamlines analysis, enhances visualization, and effectively manages outliers. Today, we will discuss how to perform equal weights binning. This algorithm divides the continuous variables into several categories, each with bins or ranges of the same width. To calculate the width, we can use this formula. Maximum minus minimum divided by x. Maximum and minimum present the maximum and minimum values of the list. X is the number of bins. To understand more this process, let's apply it on this dataset. Here we have X and we have several samples of values. You can see that the minimum value in this list is 10. The maximum is 55. Let's find the width after indicating x equal to 4 as number of bins. So the result will be 55 minus 10 divided by 4, and we will round the answer up. We will obtain 12. And now how to find the ranges? There are two ways to find the ranges. The first, if we have discrete numerical values, like the case of our example, we can do as following. First range will start with minimum, and the end of the range will be minimum plus W, the width, minus 1. The first range will be from 10 to 21. Then, to find the second range, we will apply minimum plus W. It will be the first value in the second range till minimum plus 2W minus 1. The result will be 22 till 33. So for the third range, we can write minimum plus 2W till minimum plus 3W minus 1, and so forth. But if we have continuous numerical values, the ranges can be found as the following. First range will start with minimum. It will end with minimum plus W, excluded. Second will start with minimum plus W included, and with minimum plus 2W excluded, and so forth. After calculating all ranges, the result of our categorization will be as following. From the photo, we can understand that we have 5 values in the first bin, only 1 in the second, 2 in the third, and 4 in the fourth. After analyzing our results, we can understand that equal values were regrouped together in the same range. For that, we are using equal weights binning because it's more accurate than other kinds of binning methods. And now let's try to apply binning using Tableau. For today's video, I chose to use Iris dataset. You can find this dataset easily on Kaggle website, and you can download it because it is an open access website. You need just to follow this link and download the Iris dataset. Once you have the data set, we need to connect Tableau to it, to this Excel file. And you can see that Iris dataset contains several attributes, including sepal lengths, sepal widths, petal lengths, and petal widths. And also we have some categories of this flower. Let's now open this dataset in Excel to explore it more. Go down. You will see that it contains 150 samples. And now let's switch again to Tableau, open a new sheet and drag petal lengths to the columns shelf and iris count to the rows shelf. Initially, we will get a single point because we need to change petal lengths to dimensions. Once we switch petal lengths to dimensions, the chart will display the relationship between petal lengths on the axis X and the count of iris flowers on the axis Y. By default, the relationship is shown using line chart. However, we can easily change this to a bar chart for better clarity. We can notice that the graph is a bit noisy. To smooth the data and reduce noise, we can apply equal width binning. Here's how to do it. Drag the attributes back to the data pane. Right-click on petal length and select Create, then Bins. You can rename the field and adjust the bin size as needed. Tableau refers to the width of the bins as size of bins, and you can also see the minimum and maximum values for the petal length. Click OK, and the bins measure will be added to the list on the left side. Now drag the new bin field to the columns shelf and place iris count to the rows shelf. This is the resulting chart. And now we can add some improvements to show the number of iris flowers in each category. We can click on Show Mark Labels. And now if we want to convert the axis Y to percentage of the total, go to iris count above, select Quick Table Calculation and then percent of total. You can further enhance the visualization by adding labels and changing the colors. We can repeat this process to create bins for petal width and show the percentage for this attribute as well. You might wonder why the graph remains a bit noisy even after binning. The reason is that we have different categories of flowers: Setosa, versicolor, and virginica. Also, for the first bin, the value 0 represents iris flower with petal width less than 2.267. This concludes our video. I hope you found it helpful. Thank you for watching. Feel free to let me know if you have any questions. or need further information. Have a nice day. See you in next videos. Bye bye.